So in section 2.7, we're going to be mixing together geometry and algebra here. In that we're going to be working on the coordinate plane, but we're going to be talking about finding distance from a point to a line. Because this is something that if you're interested in engineering, if you're interested in architecture, these are things that you're going to need to be able to do in those career fields. So first, just the main idea of how do we find the distance from a point to a line? Because if we picture that I have a ruler, I could put the ruler in a lot of different places. I could say that I'm measuring from C to A. I could say I'm measuring from C to B. I could pick some random place in the middle. I could put it here. But along all of those, if I put the ruler on any of those colored lines I drew, I'm going to get different answers. And so we need to have an agreed upon place to put a ruler to measure from a point to a line. And where we do that is we are always going to measure along the line that is perpendicular to our given line. So this distance right here is the distance that we are looking for from our given point along the perpendicular line to our given line. That distance is what we refer to when we say the distance from a point to a line. So kind of the steps we're going to take to do this, because there's a lot of algebra involved in this. We're going to find the equation of line L, our given line. I recommend start in point slope form because it's easy to do, and then get y by itself for a later step. Step 2, write the equation of the line perpendicular to L that goes through our given point P. I'm going to refer to this as line W just because it's a lot easier rather than having to constantly say the line perpendicular to L through P. That's going to be line W. Remember that your slope is the opposite reciprocal of L. And again, it's easiest to start in point slope form, and then for a later step, get y by itself. Step 3, find the point of intersection between L and W. So this is a system. If you have gotten y by itself in step 1 and in step 2, it just means you need to set your two equations equal from those steps. Solve for x, and then remember, we also need the y value because it is going to be a point. And we're going to call this intersection point Q. So I have point P, and now I have point Q. I just use the distance formula to find the distance between them. So referring to my picture here, step 1 is saying, let's find this equation. Step 2 says, let's find this equation. Step 3 says, let's find the coordinates of this point, Q. And if this is P, step 4 is to then find this distance. So step 1, find the equation of our given line. Step 2, find the equation of the perpendicular line through P. Step 3, find the intersection of those two lines. Step 4, find the distance between the intersection and our given point. So an example of this. Let's say that line L contains the points -5, 3 and 4, -6, and point P is at 2, 4. Now I want to find the distance between line L and point P. So the first thing I do is I need to find the equation of line L. So for that, I do need the slope. Slope is change in y over change in x. So 3 minus -6 over -5 minus 4. So that's going to be 9 over -9, which is -1. I like to use point slope form to start with. I'm going to use this for the point I'm using. So I'd have y minus 3 equals -1, parenthesis, x plus 5. I then, because of a later step, want y by itself, I'm going to go ahead and isolate y at this point. So I'm distributing the -1 to get rid of my parentheses, then adding 3 to get y by itself. And there's my equation for L. Step 2, find the equation for W. Remember that W is perpendicular to L, so the slope is the opposite reciprocal. The opposite reciprocal of -1 is +1. I'm going to be using point P because I need it to go through point P, so y minus 4 is equal to 1 parenthesis x minus 2. I'm going to isolate y here because of what I'm going to do in the next step. So distribute the 1 to get rid of the parentheses. Add 4 to both sides to get y by itself. So now, my third step, I want to find the intersection of these two lines. So it's a system of equations. I want to know what x and y are, and I have two equations. Here's L, here's W. Because I've already gotten y by itself, I just set these two equations equal to each other. If you did not get y by itself in the first two steps, you need to do it before you set the equations equal to each other. I'm going to move my x's to the left side, so subtract x from both sides gives me -2x minus 2 is equal to 2. Add 2 to both sides. -2x is equal to 4. Divide both sides by -2, x is equal to -2. Plugging that into either of my equations, I get that y is 0. So my point Q, the intersection, is at -2, 0. And this now leads me to D, or our fourth step, which is the distance. I am finding the distance between P, 2, 4, and Q at -2, 0. So I've got 2 minus -2 squared plus 4 minus 0 squared. 2 minus -2 is 4, so I have 4 squared. And then 4 minus 0 is 4, so I have 4 squared again. So this gives me the square root of 16 plus 16, which is the square root of 32. And because this is normally done in a real-life situation, leaving it as a radical, while perfect mathematically, is not perfect in real life. We tend to go ahead and round to a decimal value. I'm going to round to 3 decimal places, so this is going to be 5.657. And here is my distance. That is going to be my answer.